All right, in this section, we're going to take a look at factoring quadratic expressions that are in the form of ax squared plus bx plus c. So we're looking at that kind of standard form of the quadratic equation. We're going to end up using a method called decomposition. But while we work our way there, we're going to look at some of the mini processes that are in there, which the first thing we need to look at is just what's called factoring. And you may remember working with like the greatest common factor, GCF, in elementary school, or maybe in grade 9 and grade 10, but this is going to include some algebra to it now too, instead of just numbers. But we'll start with numbers, and then we'll kind of build our way up through the concept here. So a factor, the term factor, it's just a number and or a letter, the variable part. So a number and a letter that multiplies into another. If we take a look at the first example here, we have 3 times 4 equals 12. That's something we've worked with throughout our math careers. So 3 times 4 equals 12. That means that 3 and 4 are factors of 12. Why are they factors of 12? Because 3 and 4 are numbers that multiply to 12. Other numbers that are factors of 12 include 2, 6, 1, and 12 itself. How do you know it's a factor? One way is if you can multiply that number by another. Another way is if you can divide the number you're working with by the factor, you will get a whole number. Not a decimal. So we're not working with decimals with these. We're always going to have whole numbers. So it makes it a little bit nicer. So you could also check this out. 12 divided by 3, that's 4, which would confirm that 3 is a factor. 12 divided by 4 is 3, which confirms 4 is a factor. As long as you divide it and it gets a whole number, that's another way of looking at it. So what about numbers and letters now? Because we are working with some variables, so we need to be able to understand those too. So if we take a look at 5 times x, and I use the brackets just so we don't get the confusion with the x and the time sign. So 5 times x, we generally just write that as 5x. That means that both 5 and x are factors of 5x, because 5 can go into there and x is multiplied into there. And it's the same if we have even bigger mixes of numbers and letters, like 6x times 4x. That equals 24x squared. 6 times 4 is 24. X times x will get the x squared part. That means 6x is a factor of 24x, and 4x is a factor of 24x. Both of those can divide into that. Remember, multiplication and division are opposite operations. So if 10 times 5 is 50, 50 divided by 5 is 10. 6x times 4x is 24x squared. 24x squared divided by 6x will be 4x. So they can work conversely. So we're going to look at a focus of just greatest common factors. And so greatest common factors means that it's just the largest factor that will go into 2 or more different values. Okay, so it's got to be the same between the 2 values. So we'll do some examples here. What's the greatest common factor between 4x and 2? And so if we look at 4x and 2, we look at the factors of 4x and the factors of 2. Numbers that multiply to 4 are 1, 2, and 4. 1 times 4, 2 times 2, those all equal 4. The x is not going to be a factor because it's not common between the 2. But the 2 numbers that multiply to 2 are 1 and 2. So you may have done this kind of layout in elementary school with numbers, and then you said the greatest common factor in this case, common, is 2. 2 is the biggest number that goes into both. So the greatest common factor for this, GCF, equals 2. That's the biggest number that divides into both terms. If we jump over to here, we have x squared plus 3x. So they don't have numbers that are common because this one's just a 1, and we usually work with the 1. But they both have an x. So x squared, factors of x squared are x and x squared. You can divide x squared by x and you'll just get x. You can divide x squared by x squared and you'll get 1. 3x, well, again, we're just going to worry about the x portion. The only thing you can divide x by is x. And so you notice they both have x in them. And thus the greatest common factor here, GCF, is x. You'll also note, or hopefully notice as you move through these, that whenever we have the x's, the greatest common factor for x's is if each term has an x, remember this one didn't, but this one did, the lowest power of x, in this case, the 1x here by itself, is the lowest power. That's going to be the greatest common factor. And so you'll see that in the next one. So here we have 9x cubed and 3x. The greatest common factor between 9 and 3 is going to be 3. So you don't have to do the list here when we're factoring. You can if you need to. Usually this is side work, especially when you'll see when we get to the next type of question. But 9 and 3, the greatest number that divides evenly into 9 and 3 is 3. And if you have trouble understanding or figuring out what's going to divide in, good idea is to do a little search on your phone or your computer for a multiplication chart. And then you can check the rows and see what numbers. All the numbers in the rows of a multiplication chart or columns of a multiplication chart show the factors of that number. So 3 is the greatest common factor between the numbers, and then between x squared and x, the lowest power of x is x. They both have an x. With the type of questions we're going to be working with, if there's a common factor of x, with the variable part, it's just going to be a single x. I'm not going to try and trip you up with cubes and quartics and quintics and bigger powers of x. So we'll just keep it easy, and we'll just focus on plain old x. So if x is common between them, that'll be just a plain x that you take out. And when I say take out, you're going to see that in the next part. So here we have our greatest common factor. In this case, it was 2. In this case, it was x. In this case, it was 3x. Now, when we're factoring, or when we're asked to factor in terms of algebra, what we want to do is reverse expanding. So we want to go from so here in this example, if we were to expand this equation, then we would multiply 5x by x to get 5x squared, and then 5x by 2 to get 10x. So that would be expanding it. So we want to take this is what we're starting with when we're factoring, and we want to reverse it back to this, to the multiplication. So to do that, we need to look for the greatest common factor between these two terms, which in this case is 5x. 5 and 10, the greatest common factor is 5, and x squared and x, the greatest common factor is x. So 5x is our greatest common factor. And then how the process works, because normally we don't have this in front of us, we just have the question and we want to get back to that answer. So we have this here set up. So now I've found the greatest common factor. I put brackets. Always put brackets. Every time you're going to have to find it and then put brackets. And you just figure out what's left over after you divide each of these. So we're going to undo the multiplication. 5 divided by 5 is 1. And a lot of people find this more comfortable to put ones. You don't usually have to put the 1 when there's a variable there. But the next part will be x squared divided by x. So 1x. Whenever you have x squared, remember that was x times x. So when we're dividing out one of those x's, we're just left with another x, because x times x is x squared. The next part, 10x divided by 5x. 10 divided by 5 is 2. And x divided by x is 1. So it's 2 times 1, or just 2. So you could write it like this. Or more commonly, if you were to look at like an answer sheet for this, what you would see is you wouldn't see the 1 there. You would see 5x bracket x plus 2, which now looks like that. So again, this 1, a lot of people put it there as they're learning this because it feels more comfortable to remember that, yeah, 5 divided by 5 was 1, so I put down the 1. But generally, you won't see that. It'll just be x. So what we're doing is reversing it. And how do you know you got it right? Because it's weird and confusing. You can multiply this now. This is an expanding question. And if you multiply this, you should get this same thing. It should go back to, if you take your answer and multiply it, it should get back to the question. 5 times x is 5x squared. 5 times 2 is 10x. So that would mean it's right. So these are nice in that you can actually check your answers. And once you're comfortable with factoring, you can also check your expanding questions and see if you got the right answer. Some examples to work with this. So we want to factor. This is also called common factoring because we are finding that greatest common factor. So we often call it common factoring as the type because there are different ways of factoring depending on the type of question. We'll look at some more later in this lesson. But here we have x squared minus 4x. So we want to factor these. So there's no numbers that are the same. No common factor for the numbers because, again, we don't worry about the 1. So it's just x squared and x. So that means the common factor is x. I put a bracket. X squared divided by x just leaves x. Negative 4x divided by x will just leave the negative 4. The x's will negate each other when we divide it out. X times x minus 4 in brackets. And if we want to check that, x times x, that's x squared. X times negative 4, negative 4x. So that would be right. Moving on, in this one, we have some numbers, no common letters. So 2 and 6. What's common? What's the greatest common factor between 2 and 6? Both of these can be divided by 2. So we'll divide by 2 as our greatest common factor. 2 divided by 2 is 1x, or just x. And 6 divided by 2 is positive 3. And again, we can check this is right. 2 times x is 2x. 2 times 3 is positive 6. In the next one, it's got 3 terms. What do? The exact same thing. We look for what's common between all 3. So we go through and look. They don't have any letters. That would be the same because this one doesn't have a letter. So we're just looking at the numbers. 15, 6, and 9. All of these can be divided by 3. The biggest number they're all divisible by is 3. So our common factor here is 3, bracket, and then 15 divided by 3 is 5, and the x squared stays. 6 divided by 3 is 2, and the x stays. And then 9 divided by 3 is 3. And again, just like the rest, if you want to check, you should be able to multiply this back out and get this. 3 times 5 is 15 with the x squared. 3 times 2 is 6 with the x. And 3 times 3 is 9. We're all good. And again, there may be cases where there's other possible numbers that could go in, but you're always looking for the biggest number. So make sure you're always picking the biggest possible number that you can take out. This is where you'll want to do some practice with this. Get comfortable with common factoring. Try some of the practice worksheets and then you can move on into the next process, which is factoring trinomials. So you may wish to pause here, come back to this later after you've done some practice with common factoring. But we're going to just put it all together here in one big giant video. So this will be a little bit longer, but covers both sections. So it's really two parts. So here we're factoring trinomials is generally what they're called. That's when we have 1, 2, 3 terms. Or just, we'll be working with quadratics in standard form. So the method we use here is often called decomposition. We're going to decompose it into parts, break it down into parts that we will factor subsequently from there. So I'm not going to put any trick ones out there. There are cases where we can't factor. If you have a parabola that doesn't have any zeros, then it won't be factorable. But we're going to focus on ones that we can factor. So don't worry. There's not going to be a case where it's not factorable, which does come up on occasion. We're avoiding that kind of stuff. So these will all be factorable. So it's just a matter of walking through this procedure. And I would keep this procedure handy. There's 5 steps to it. It seems long because I'm taking up the better part of a page, but really it's just a few lines of work. I'm just trying to be descriptive with it. But this same procedure will work for all your factoring of trinomials, all your decomposition type of situations. It will work for them. There's some shortcuts that you can take on certain types of questions, but rather than try and confuse you when to use a shortcut, when not to, this method works. So the best way to do is kind of walk you through an example of it. There's not really a formula to use. It's a procedure. So as long as you follow this procedure each time and practice this procedure, you'll start to get the hang of this. So we're going to factor 3x squared plus 17x plus 10. So here I've written it out. And the first thing we need to do is multiply the first and last numbers. The proper term is coefficients, but we're going to multiply these first and last numbers only. We're not worried about the letters. So 3 times 10. And we're going to write that on top. I like to put this bar here. And so I write it over top of this middle number because these are going to be what we work with next. So 3 times 10 is 30. So I've written that up here. Now in the next step, what I want to do is find 2 numbers that multiply to 30 and add to 17. And make sure you look at them in that order because it's easier to find. There's less numbers that multiply to 30 than there are that add to 17. So it'll be quicker. So what I did here was I just started listing numbers that multiply to 30. You might not have to do this if you recognize the pair right away, but here I listed all the pairs of numbers that multiply to 30 and then found a pair that would also add to 17. So I did 1 times 30. There's no way I could get those to get to 17. And we could use positives and negatives. In this case, it ends up being just positives. The only time you need a negative sign is if one of the signs in here at least one sign is negative. If both of these are positive, then everything's positive. And you'll kind of see these, hopefully we'll see these patterns as we do these. But these could potentially be negatives, so do keep that in mind. But 1 times 30, 1 and 30 won't get us to 17, but 2 and 15 will. 2 plus 15 is 17. So 15 and 2 are the pair that works. It has to satisfy both. Okay? It can't just add to 17. It can't just multiply to 30. Those two numbers have to be able to do both things. And so this is the pair that works. The order you write them doesn't matter. You could write them in a different order, and it'll just change the order that things appear in the next steps, but you'll end up with the same values just in a different order. But it'll still be correct. So I found my pair of numbers, it's 15 and 2. So what I need to do now is I need to rewrite the middle number. So that was the 17x. I need to rewrite that as the sum of these two numbers. And they were both positive, so it ends up being plus, but it could, if one was a negative, it might be a minus. And you'll see that in examples later. So I've rewritten that. And note, it's 15x plus 2x. I put the x's there because it was 17x. So 15x plus 2x is 17x. And you see we're kind of going backwards with our expanding of these 2x2 terms. This is like that middle step before we finish it. Now what you want to do is common factor the first two terms. So that's 3x squared plus 15x. And then we're going to common factor the next two terms, which is the plus 2x plus 10. So starting with the first pair, 3x squared plus 15x, common factor that, I get 3x, and then I'm left with x plus 5 in the brackets. I'll use whatever sign is here, positive or negative, on this next part. And so I use the sign of positive here, and the common factor was 2. So plus 2, and I divide both of these. I divide out the plus 2 from both of these, and I get an x plus 5. If you've done this right, then what you'll have is these two brackets will be the same. If they're not the same, you may not have pulled out the common factor, or you might not have the right pair of numbers from the middle here in the previous step. But once you do that, you'll notice these both have a times x plus 5. So what we're going to do is factor out that bracket, x plus 5, and then in another bracket, we're left with 3x plus 2. This is another common factor. It looks a little weird with the brackets, and a lot of people are just comforted by that, but it's always going to be the same thing. Whatever's in the brackets, you write it out here. That's the factor, and then that's what's left. And so we put that in a bracket. And we're done. And you could expand that out, and you'll get back to the original, which was the 3x squared plus 17x plus 10. So these 5 steps work all the time when we're factoring these trinomials. So we'll use those same steps here on these next two examples. So I have 5x squared equals 22x plus 8. And so I'm going to multiply 5 times 8. And that's going to give me positive 40. So I need two numbers that multiply to 40 and add to 22. Well, 1 times 40. I can't get a 22 out of those. So we'll try the next pair. 2 times 20. 2 times 20 equals 40, and 2 plus 20 equals 22. There's my numbers. A positive 2 plus a positive 20. So I can stop there. I don't have to keep writing pairs of numbers because I've found the right pair. So now I'm going to rewrite that middle term. So instead of 22x, I'm going to have plus 2x plus 20x plus 8. So I've rewritten 22 with those two. Again, order doesn't matter. You could do this with 5x squared plus 20x plus 2x. You'll get the same result. Like this one here, you'd get the same brackets, just they would be in a different order. So this would come last, this would come first. Doesn't matter though, whichever way works. So whatever way you write down the numbers is perfectly fine. But now I got a common factor this first pair, 5x squared and 2x. So the common factor there is just x, and I'm left with 5x plus 2. Now I got to factor this second pair, remembering to use this sign, so it's a positive sign. 20x plus 8. Well, common factor is just a number here, 20 and 8. Is going to have a common factor of 4. And when I divide that out, I get 5x plus 2. I got the same brackets. So that means I'm on the right track. I write out that bracket because I'm factoring it out. And then I'm left with x plus 4 in another bracket. That's it. I've now factored that down to its component parts. In part B, we got some negative signs. So now we're going to end up with some negative numbers to work with, but the process is exactly the same. Step 1, multiply the first and last term. 4 times negative 6. Don't forget about the negative sign there. 4 times negative 6 is going to be negative 24. I need to find two numbers that multiply to negative 24 add to -5. So I'm just going to start writing numbers that multiply to 24. 1 and 24. No way those are going to add or subtract to get to 5. So I move on. 2 and 12. No, they're not going to get 5. 3 and 8. Well, yeah, that would work. +3 minus 8. That's going to get -5. +3 times -8 is 24. There's my pair of numbers. So now I'm going to rewrite that -5x with those two values. 4x squared plus 3x minus 8x minus 6. So again, rewrote the -5x with those two values, making sure I keep the x in there. Common factor the first two. In this case, it's just an x. I'm left with 4x plus 3. Again, I need to use this sign, so I'm going to use the negative. And then common factor 8 and 6, that's going to be a 2. Close the bracket. -8 divided by -2 is +4. And then the x, -6 divided by -2 is +3. Look at that, my brackets are the same. If you don't use that negative sign and use a +2 there, these are going to be negatives and they're not going to be exactly the same. And if you see they're the same numbers but wrong signs, double check that sign. But now I got the same bracket, so I just write that out, 4x plus 3, factored it out, and I'm left with x minus 2. And so that there is factoring by decomposition when you have a trinomial. Again, the factoring tends to be a little more confusing for people than the multiplication, because a lot of it comes down to knowing your multiplication tables to find the right numbers and then just following procedures. The more you practice, the better you'll understand them. You'll start to see the patterns. So just work your way through some of the practice questions and you'll start to pick up on this stuff.